Welcome to Cheenta Statistics and Data Science. Today we're going to solve this problem from CMI Data Science 2022, problem number 11 and 12. So let's start with problem 11. So it says, which of the following plots correspond to a bijective function? So there are four plots given and we have to check which one of them or more than one of them correspond to a bijective function. So the plot one is basically this the see a bijective function is bijective if and only if it is both one to one and on to. That means it is both injective and surjective. Now, what that means is, see, injective means one to one means that distinct elements in the domain must take distinct images, must assume distinct images, right? That's the definition of one to one or injective. And on to means that each element in the codomain must have at least one pre-image, right? But at least one. So basically bijection is combining these two properties. So basically it says that every element in the domain is going to be projected into something distinct element, some distinct element, and every element in the codomain is going to be the image of exactly one element from the domain basically. So here graphs 1 and 4 are actually bijections by inspection. Why? So basically this is nothing you have to nothing you there's nothing to write about, to be honest, at least in a objective problem. So basically see, let's check about first check option 2. See this option, this particular graph. See this does not even qualify to be a function. Why? Because see, it fails the vertical line test. If I draw a vertical line here, it actually intersects the curve at more than one point, right? Which is not supposed to do that, because it's not, it disqualifies to be a function, right? So it is not a function. If I it fails the vertical line test. So obviously it's not a function, so there is no point of talking about whether it's bijective function or not. It's not even a function, right? So yeah, option 2 just gets ruled out. Now option 3, see, it actually fails the horizontal line test. That means if I draw a horizontal line here, it fails the horizontal line test. Why? Because see, if I draw a horizontal line, or if I don't even have to draw a horizontal line, see here that at the point 0 the function is 0, right? And at this point, this particular point, again it is 0. That means it is not a one-to-one function, right? Because the zero values that you assumed both at 0 and this point here must be a point, some real number between some, say, alpha or something. So it does not qualify to be a one-to-one function and obviously not a bijective function. Now option 1 and option 4, they're both this one is strictly increasing, right? So every element here in the 0 1 domain is has a image, right? Every element has an image, has a distinct image, right? Every element has a distinct image. And if I choose any element from this codomain, from this 0 to 1, if I choose any element and just try to produce a pre image of it, I can do that, right? Because see, if I choose here, just I draw a line parallel to the x-axis and it touches this curve, and if I just go down parallel to the y-axis, then I get to some point. So every point in the codomain is actually the image of some element in the domain. So it is both one to one and onto, right? It's both one to one and onto. In fact, this looks like the function of y equals to x, right? Just in the domain 0 to 1. So option A qualifies, and option B is similar. See, it is decreasing. That's the only difference. It is decreasing, right? So here also, if you take any element in 0 to 1, it obviously has an image, and it obviously has an image, right? And if you take any element from here, the y-axis 0 to 1, it also has some pre-image, right? Some pre-image in the domain. So obviously, option 4 also qualifies to be a function which is both one to one and onto, and hence bijective. So option A and option 1 and option 4 are both bijective functions, whereas 2 and 3 are not. So option C is true, right? Very easy problem. So let's try to do the next problem, problem 12. So it says a relation R on the set A equals to A, B, C, D is defined by reading the columns of the following table from top to bottom. If the column in the table reads x, comma y, comma 1, it means x is related to y in R. If a column in the table reads x, comma y, comma 0, it means x is not related to y. So this is the column for the elements in the set A. And for instance, from the fifth column, we have AB belongs to R. And from the second, we have BA not belongs to R. Why? Because the fifth column says that this fifth column says A, B, 1. That means A and B are related. So A is related to B. So A comma B, this ordered pair is a member of R. But here the second one, B comma A, B A 0, this one, this B second column, B A 0, it means that B comma A is not a member of R. See, another relation is on the set A is defined as, for any xy in A, the ordered pair x comma y is in S if and only if there exists z in A such that both x comma z belong to R and z comma y belong to R. So which of the following pairs are in S? So there are four options. So we have to check whether they are in S or not, right? So let's try with the first one. See, this one, A comma A. See, A comma C actually belongs to R. See, A comma C. A comma C here, this one, this column, A comma A C one. That means A comma C belongs to R, right? A C one is there. So A comma C belong this ordered pair A comma C belongs to R. Again, C comma A, this one, C A one, this column, the third column. This one C A one also means that C comma A also belongs to R. That means we have actually found out an element such that A comma C belongs to R and C comma A belongs to R. That means A comma A also belongs to S, right? Because the property says that if we have to find some elements such that this kind of thing holds, right? So first option is true. But that means not true. Here is not a problem of true and false. So basically this element A comma A is actually an element of S. What about option B? So option B says B comma B, right? So here B A, B B and B D all are not members of R. See B A 0. That means B comma A doesn't belong to R. B B also 0. Again B D also 0, right? So all of them are 0. So BC is 1. BC is 1, right? That means B comma C belongs to R, but C comma B doesn't belong to R. Why? See, C comma B here, C comma B is 0. So there is no C comma B in R. Therefore, BB does not belong to S, right? So B comma B does not belong to S. So option C, C comma C. Let's check whether it belongs to S or not. See, again, C comma A belongs to R because there is C A 1. So C comma A belongs to R, right? Again, A comma C also belongs to R. See A C 1. So A comma C also belongs to R. So here the element we have found out is A because C comma A belongs to R and A comma C also belongs to R. Therefore, C comma C belongs to S, right? So option C is belongs to S. Lastly, option D comma D. So D comma C and C comma D actually belongs to RC. You can easily see that from the graph. See here, DC1, right? DC1, that means D comma C belongs to R, and again CD1, that means C comma D also belongs to R. That means D comma C and C comma D both belong to R. That means D comma D belongs to S, right? So basically AA, CC and DD all belongs to S, right? Only BB doesn't belong to S, right? So among these four options, AA, CC and DD all belong to S, but option B doesn't belong to S. So yeah, it is a very easy problem. Just you have to understand what the problem says. It just says that we have to find whether exists certain element with this property. If it exists, then the element belongs to S, and otherwise it doesn't. So yeah, very easy problem. You just have to understand how to read it. That's it. So yeah, there you have it, the solution to this problem. So do like, share, and subscribe to the channel for more exciting problems. See you till next time.